class, this is Mrs. Leach. Our lesson today is on estimating and adding fractions with rectangles. Our learning targets for today's lesson are: I can estimate sums with benchmarks, and I can add fractions with unlike denominators using rectangles. All right, so we've seen this table before. We've used benchmarks to estimate numbers before. So our benchmarks are 0, half, 1/2, and 1. So we want to look at the fractions that we have down below under our table to see where they belong. Let's look at 4/5 first. 4/5 is really close to 5/5, which is the same as 1/2. So that would be closest to 1/2. So we write it in that column. Let's look at 1/8. 1/8 is a really small fraction. That's really close to 0/8. So that would go by 0, or under 0. Okay. 2/4, well, I know that 2 is exactly half of 4, so that would be equal to 1/2. So I'm going to put it in the 1/2 column. 1/6, again, this is a pretty small fraction. It's only 1 out of 6, so that's going to be close to 0. I'm going to put it in the 0 column. 3/8. Well, 3 is not a lot, but it's really close to 4/8. And I know that 4 is half of 8, so that would be really close to 1/2. I'm going to put that in the 1/2 column, because it's closer to 1/2 than it is to 0. 0/3, well, that's pretty obvious. That one would go, there's none represented there, so that would be 0. So we'll put that there. And we don't usually write fractions like that anyway. And the last one is 9/10. Well, 9 is really close to 10, so I know that's really close to 10/10, which is 1/2. So I'm going to write that in the 1/2 column. So that is how we use benchmarks to estimate whether a fraction is closest to 0, 1/2, or 1. All right, now we're going to estimate sums with benchmarks. Remember that a sum is just the answer to an addition problem. So we know that we will be adding, but we'll be estimating to get our sums. So our first problem is 7/8 plus 5/6. So first I need to estimate 7/8. Well, 7/8 is really close to 1. And 5/6 is also really close to 1. So I know that my answer is going to be about, because it's not an exact number, about 2 wholes, because 1 plus 1 equals 2. All right, our next problem is 7/12 plus 2/4. Well, 7/12 is really close to 6/12, and 6/12 is the same as 1/2. So I'm going to estimate that to be close to 1/2. Plus 2/4 I know is the same as 1/2. So that's like adding about 1/2 plus about 1/2, which I get about 1/2. Okay, our third problem is 9/10 plus 1/20. So 9/10 plus 1/20. 9/10 is really close to 1/2. And 1/20 is really close to 0. That's not much at all. So 1 plus 0 would be 1. So our estimate is about 1. Okay? Our next problem is 1/2 plus 1/10. Well, 1/2 we don't really have to estimate because it's exactly 1/2 if we use our benchmarks. And 1/10 is really close to 0. So 1/2 plus 0 equals about 1/2. All right. And our last problem is not showing up on our board, so I'm going to write it off to the side here. This one's a tricky one. This is a special problem. It's 11 twelfths plus 1/4. This problem is difficult because of this number, the 1/4. 1/4 is exactly midway, exactly halfway between 0 and 1/2. So we can't really say which one it's closer to. But when we're adding, we can look at it and say that 1/12 is really close to 1. And then we just know that it's going to be something, I mean, we can kind of go like this, and we just know that it's going to be greater than 1. So that can be our answer for that. Greater than 1. Those fourths can be tricky. So you have, like if you had 3/4, you would be halfway between 1/2 and 1/2. So you really have to look at that first number to tell you if you're going to be greater than 1/2, less than 1/2, etc. All right, so here is our dot paper that we've been using for adding fractions, or for just representing fractions. Today we're going to use them to actually add fractions. So our problem is 3/4 plus 4/5 equals blank. Since we have unlike denominators, we have some steps to follow when we're doing this on a rectangle. So our first step is to estimate. Will the sum be close to 0, half, 1, or greater than 1? This tells me how many rectangles that I'm going to need to draw. So if I estimate 3/4 to be, well, we know that one's tricky. That one's right between 1/2 and 1, and 4/5 is really close to 1. So I know that it's going to be greater than 1. So I'm just going to make a little note to myself of my estimate so I can check it later. I know I'm going to need more than one rectangle then to draw this. Okay, so number 2 says choose the right size rectangle. Well, for this, we would want a rectangle that can hold fourths and fifths. So we can do a 4x5 rectangle. 1, 2, 3, 4 by 1, 2, 3, 4, 5. That's a little crooked. That's okay. Then we're going to find the sum by modeling on the dot paper. So here's how we do that. We're going to show 3/4 shaded in first. So I divide my rectangle into fourths, and I shade in. Oh, and I said I would need more than one rectangle, so I better draw my 2 rectangles now. Another 4x5 rectangle. They have to be the same size. Okay, so if I divide this into fourths and I shade in 3/4, that's what we've modeled the first part of our problem there. Then I need to model 4/5, adding 4/5. I'm going to do that in a different color. So fifths would go the opposite direction. Excuse me. So fifths would go this way. Okay? So we want to show 4 of those fifths. So how do we get an answer? We've modeled the 2 parts of our problem, 4/5 and 3/4, but we still need to find the sum. So the way we do that, I'm going to choose a different color, is to break it up into equal pieces. So if I break up both of my rectangles into equal pieces, I would have 20 equal pieces. I would have 20ths. Then we can just count how many 20ths are shaded now that we've added them. We wouldn't count the ones that aren't shaded because those were not in our addition problem. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So our answer would be 31/20ths, which is an improper fraction the way it is, but that's okay. So we've found our sum by modeling on dot paper. Now we want to go back to our estimate to make sure that our answer is reasonable. So 31/20ths, is that greater than 1? It sure is, so our answer is reasonable. You could take this a step further and find the mixed number for 31/20ths for your answer. All right, we're going to do another sample problem. So this one is 2/5 plus 1/3. So first step, estimate. Will the sum be close to 0, half, 1, or greater than 1? This tells us how many rectangles we need to draw. 2/5 is probably closest to 1/2, and 1/3 is close to 0. So we know that we're only going to need one rectangle. So our answer will be close to between 1/2 and 1. Okay? Choose the right size rectangle. Well, it needs to fit fifths and thirds. So we can do a 5 by 3 rectangle. We don't need more than one rectangle for this problem. 5 by 3. Okay? So we've chosen the right size rectangle. Now we're going to model it on dot paper and find the sum. So 2/5, I'm going to divide this into fifths. And I'm going to shade in 2 of them. Okay? Then, and I could keep going and draw the rest of my fifths, but we don't need to do that. And I'll show you why in a second. Now I need to show 1/3. Now if I were to show thirds, I would go this way, right? This would be thirds. But I can't do that because some of them are already shaded in blue over here. I just need to count how big is a third. How many square units is in a third? There's 1, 2, 3, 4, 5. So all I have to do is shade in the part that hasn't been shaded in blue yet, shade in 5 square units, because that's the same as 1/3. So that's 3, 4, 5. So I have 1, 2, 3, 4 that are left unshaded. Okay? So I've modeled 2/5 in blue. I've modeled 1/3 in green. Whoops. In green. And now I need to find my sum. So again, I need to break my rectangle up into equal parts. I'm just kind of coloring over those ones. So now we have 15ths. How many 15ths are shaded in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 15ths is our answer. Okay, so then I need to go back to my estimate to make sure that my answer is reasonable. Is 11 15ths for my answer, is that between 1/2 and 1? Yes, it is, so my answer is reasonable. And that is how you estimate, and add fractions using rectangles.